So why if I remember last week I already explained it, why I draw in the N side the distance a bit narrow. Okay, this is a little bit wider because the concentration of the donor and the receptor. Because that's the purposely we want to produce a very sharp, and gender the electrical field distribution, right? Later I can explain again. So now this is a second, okay? So this is x1, this is x0. Like x0, sometimes we don't pronounce the zero as a zero, none, N-O-N-E, none, okay? So x0 is the origin, like the origin of the position of the junction. And the x1 means the edge of the how we call this is depression zone. Sometimes we call this we call this a depression zone. Depression means I deplete, okay? 我把它清空了. Why I call deplete means I deplete the phosphide atoms, the electron of this area. Okay, all the fifth electron of the phosphide already be transported, or we call deplete. Okay, so we call depletion zone. Okay, so both this area we call depletion zone. All right, so this is the edge of the depletion zone. After this depletion zone is what? There's no electrical field. Okay, there's no charge, the positive charge ions beyond this edge. Okay, I'd like to stop here for a second. Any questions? Yes. Any questions?
So the equation don't become older when the device gets apply field.
Yeah, good question, yes. When, remember we call this a full voltage and then reverse the voltage, right? So once the contact, right, in a very short period of time, okay, a fraction of a second, then the viewing potential will be established, right? Once the viewing potential is established, then everything stops, okay? So means we have this electrical field. And this is N. But for this question, is asking if I apply a bias, okay, 偏压. Yeah. So for this case, we call forward bias, right? If I just apply very small amount of the forward bias, I will reduce what? This depletion zone, I will reduce. Because I provide what? Simply think, I provide an electron to replenish, right? Replenish is 不再给. So I kind of diminish, 把它消失掉. Positive charge ions, the phosphate, right? Okay, right. So where we are now? Okay. So here we understand if I kind of integrate from the origin of the x0 means origin of the junction 2x1 means the age of the depression. I'm going to get the Q information. Okay, so yeah, for this point, I like to specify this electric field is average. The average electrical field. So look at so the average means if I assuming this is a linear relationship. So the average electric field is what? About half of maximum. Okay, so we doing the same thing, right? In the equal sign, the right side we do the integration. Also, the right side we also do the integration from x1 to x1. Okay, so this is those are constant, right? Because we assuming we are doing this, we make this constant, we doing this junction, the contact at the constant temperature, right? And the Q is so sometimes we kind of mix using, right? The Q is equal E, okay? Sometimes. So those are the constant parameter we can put ahead of integration. Right. So then, after the integration, we know the integration. Relation. This represent the concentration of the electron at the edge of the depression zone. Concentration of the electron. And then the concentration of the electron at x naught is the concentration, the P region. And then we also know the hopefully you still remember what Ni means, intrinsic concentration. Right? There's no any doping in the silicon, means pure silicon. What's N mean? For the concentration of N silicon. What's Np mean? The concentration of P silicon. So Np equal NNP. concentration electron in N silicon is roughly equal to the doping, the acceptor doping. This is the concentration of donor. Means phosphorus. Okay, so end up the potential, the building potential. So that's the final goal. We want to understand the building potential is highly related to the doping concentration for the donor and the acceptor, and also the intrinsic concentration. So please. So next, we're gonna draw the energy band diagram for the PN junction. We're gonna draw this is the first one. Energy band. Energy band diagram. So for the N side, okay, the N silicon side. So this is EC, this is EV. Right. So I'm assuming at this point you guys already know, okay? So for the intrinsic silicon, what's the position for the EF, the Fermi level, in the middle of band gap? But for N silicon, the Fermi level will what? More close to the EC, right? How about P silicon? EC, EV. So for the N silicon, where's the Fermi level? Close to what? EV. Okay? So the energy band